Welcome to Ask and Learn.
It's a question in which we have to deal with data. So I'm just putting out the data over here that we're dealing with. Hopefully, two members, so it's actually pretty doable. And then we have a capacitance in the picofarad, which is 90, 250, 350, 450, 800, and 50. This is an experiment in which the students were given an air-free capacitor and the areas are different, but D is the same, and we don't know what D is. So they made the measurements of the area at the capacitance, and they had this table of data, and we want to figure out what D is. Okay, so let's first start right out this in the C equals epsilon naught times area over D. So doing here, we know what capacitance is, what it is, and we're looking for these two numbers. We can find this ratio of the epsilon naught over D. Because we know epsilon naught, we can find D. So if you've done an experiment before, or if you have not, I'm teaching you right now, is that you will draw a graph. I'm just drawing it by hand. You probably have a better way of doing it. You're drawing a graph with the x-axis being area square, and the y-axis capacitance in terms of picofarad. And then what is, you use the appropriate unit, say 0, 0.02, 0.04, 8, 10, 0.10, 0.12. Capacitance ranges to 1,000, so I just do 200, 400, 600, 800, 1,000, and 1,200. What you do is you plot it. You say 0.01 corresponding to 90. Okay, and this point is roughly here. 0.04 is 340. 0.06, a little bit over 400, 450. Okay, I might need to draw a couple references. This is 500, so this is 4. 0.9 is here. This is 800, and then 0.0 is a little bit over 1,000 of these lines, and then you draw a straight line that goes through as many lines as possible. And so for me, I think it's probably somewhere. Maybe I should try to probably more like this. So you draw a line so that it goes through as many points as possible, and for the points it does not go through, like these 2 points does not go through, that distributed evenly on top of the line and below the line. So that's how you draw a best linear fit by hand. You can also ask Excel or ask some fancy programs, computer programs, to do it for you. They will give you much more precise answers. But then what you do is you look at the slope of it. And how do you find the slope? Well, for the slope, if it goes through some points, you can points it goes, and then delta y over delta x. If it does not go through any points precisely, it's also nice to like find a point over here, read out the x and y, find a point, read out the xy coordinate, and again do delta y over delta x to find out. And the slope is to be epsilon d. So I actually used a spreadsheet to help me calculate the slope of the best fit line, and I got the number of 8606 times 10 to the negative 12 farad per meter squared. So 86 is the number I got adding these units. So from that we can find because epsilon over d is a slope, so d is epsilon naught over slope, and epsilon naught is 8.85 times 10 to the negative 12 Faraday per meter. This is 8606 times 10 to the negative 12 Faraday per meter. So by inspection, it's around. Indeed, 1.03 times 10 to the negative 3 meter, which is around 1 millimeter. So that's roughly the amount of distance between the two plates of the capacitor.